So, good evening, everyone. Thank you very much for joining us for the solution for today's daily challenge. Today's daily challenge was all about trying to create an in-out board or a fire register for a commercial building. I'm just going to share my screen with you to show you what that meant. So here we've got the brief from the challenge from earlier. So as an employer, I'm constantly faced with the challenge of not knowing where my employees are around the building. And along to the days where I used to have this board where where people, when they came in, manually would set themselves to in or out so that I could see who's actually there, who isn't. And whilst calendars these days are great to show you if someone's in a meeting, out with a client, out on site or something, they usually don't show when someone is actually coming into work with flexible working hours, or they don't show you when someone's taking a lunch break. Hence, the quest for today, or the challenge of today, was to try and create a digital version of such an in and out board where I can see who's in the building and who's out, and do that without any additional hassle for employees. So use the existing locks on access control system where people are using their key fobs, like the NFC key fob that I've got here, and using that information to create myself such a monitor. Further, in the event of a fire alarm, that the status of that in and out board gets locked so that no further changes can occur. Even if someone goes out of the building, goes out with their NFC token or by entering their access code, so that we'd have a definite register, fire register, to tell us who was in the building at the event of the fire alarm. And finally, as a little extra challenge, we said, wouldn't it be nice to actually know how many hours someone actually was there that week? How many hours has someone worked from an employer's point of view, to see, with all this flexible time, lunch breaks and everything going on, how much time are people actually in the office? So let me jump over to my config here. And I would like to go through to tell you what I've already set up, and then go through the solution with you. So I've got my configuration here. And as you'll be able to see, I'll just clear my filter here quickly. First of all, I've created myself two users already, Bob and Jane, who are going to be my two employees. Of course, there can be as many as you like. You can expand this list, but all we need to prove the concept is two people. So I've created myself two employees, Bob and Jane. I have also already assigned NFC tags to each one of them. So I've got two NFC tags here. To be honest, I can't remember whether this is Bob and this is Jane or vice versa. They do look remarkably similar. Not the actual people, just the NFC tags. So we'll see in a moment who's who. But they've both had an NFC tag assigned to them. And I've assigned user IDs to them. Bob is employee 00001, and 00002 is Jane. What I've also done is I've got my mini server here. I've already learned in the extensions that I've got in my demo case here on the right. And I have already, on the tree branch, learned in the two NFC codes touch, which I've fitted to my demo wall here. One of which is on the outside of the building and one is in the entrance. Both of them controlling obviously the same door. So one for letting people in from the outside and vice versa. So that's how far we are. Now what I'm going to do, I'm going to get straight to it. I will add my two NFC code touches to the page. I'm just going to add one, add the second one. I'm not going to do anything to the settings inside them. Just going to drag them here onto the page so we can see one is outside and one is on the entrance area. The first thing, if we're saying we already have a locks on control system for access control, then there must be obviously something that unlocks a door when someone authenticates. So I'm going to grab myself one digital output, which I've already named door release here. That's my door release. And output one on each of those NFC code touches, trigger set door release. So that's, if you like, my access control system. For clarity, I can also label the outputs quickly. It's done it here for me. It's copied in door release straight away from what I've connected. It's done the same here. Door release has been copied in. And if we like, we can quickly save this in the mini server and just make sure that that is working. So whilst that saves in the mini server, I am also going to open up the web interface here for my mini server. Here we are. So all we should have on there at the moment is we've got access control here, 2 door releases, one in the entrance area, one on the outside. And we can now find out who's Bob, who's Jane. So if I hold one tag to this, the door has unlocked. We can check that quickly. That was the reader on the outside. Have a look at the history. Need to set myself a user interface password to see that. I'll come to that in a moment. Let's do that. And let's also quickly find out what I've got here. I'm still showing a tracker. I'm going to hide that tracker. That was from preparing earlier. Let's take that tracker off out of my configuration. And I'm just going to remove the user interface password so I don't have to keep entering a password every time I want to show you something here. Of course, if this is a security sensitive function, then you should leave that, that box ticked on a real installation, because essentially otherwise someone can unlock the door through just clicking on the block in the user interface. So let's save that again in the mini server. And I'm going to go back to my user interface with the mini service rebooting. Here we go, categories, access control. Now, if we go to the outside and we have a look at the history, we can see was released by Jane. Let's see who this one is. So that is Jane, employee number 00002. I'll leave Jane over here, and this should then be Bob. Just double check that. Here we go, that is Bob 001. I'm gonna put Bob up here. Hope I'm gonna remember that. And we can also see quickly what happens if I go to the entrance. Here we haven't got any history yet, so I'm going to take Bob. This is on the inside, on the entrance. Again, unlocks the door. Same here. Jane unlocks the door. So we know that the permissions are right, and we can see here that the NFC tags are being read correctly. If I showed you this in live view, or if I showed you my demo case, then of course you can also straight away see that the door release, every time I hold a key fob to the reader, the door release is actually working. So that's the access control system. And now we want to tie this logging into it. And the easiest way of doing that is obviously directly coming from the NFC code touch blocks. The challenge that we've got is that in live view, based on the Q1 output, we can't see whose tag is whose. We can just see that the Q1 output goes on. It's just a digital signal, no matter which tag I use. So it doesn't matter which tag I use, that output just goes on. However, there's a couple extra outputs that we can use. And one of those outputs is the TQU output. T standing for text, TQ standing for text output, and U for user. So if we hover over that or read the description, it tells us that this is a identification of the last authorization, i.e. the user ID, username of the NFC tag, or the code, the PIN code used. So if I show that on this block, then we can see there that the last user ID was 00001. And if I do the same on here, then we can see the last user ID used on that block was 002. Now, if I take my code here, which is Bob, so 0001, and I hold that, the top reader, then please observe what happens on that reader. It changes to 0001 here. Just going to move these two blocks the other way around so that they match the way that my NFC code touches are mounted on my wall. So the top reader on the wall is now also the top one here on the page. There we go. So that output tells us which the last successful authorization was. And what we can do, we can, based on that output, create a trigger to say someone has come in or someone has come out. And the easiest block we can use for that is, of course, the switch block. So the switch block, as you'll all know, can just take an input signal, either a trigger which toggles the output, or we've got here the reset and the on one, and we can say that if we use those specific ones, we can now say every time that someone comes into the building, we want to set the person to having arrived, and every time someone leaves the building, we want to reset this to say that the person is no longer in the building. But we need one block in between the NFC code touch and the switch block to decode that user ID. And the block that we want to use for that is a block that's been added newly in version 10.3, which is partly why we picked this daily challenge to show you this new block. And that is a block called pulse by. And the pulse by block, what it does, every time the search pattern, which can be defined here, is matched, it outputs a pulse on the output queue. And the search pattern can be made up out of either specific characters. So it could just be directly a string like hello or anything that you like. And you've also got the option of using wildcard characters. Wildcard characters, as it says down here in the description, are characters that match either one or multiple characters at a time. The star means you can have any characters, any number of them, before you then try to match the string that you're entering. Question mark means that you can have exactly one character before you then match the string. And of course, you can add wildcard, you can add multiple wildcards, just as in the example there at the bottom. I'll let you read the example at the bottom to maybe understand that a bit more. Now, I know exactly what my IDs are that are going to be coming in here, so I don't actually need to use a wildcard. I can simply say, if the pattern is 00001, then I know that is Bob. And I could just give them this block a name and say, Bob arrived. Oh. So Bob arrived, that would be Bob coming from the using the outside reader, his ID showing up on that reader. And when he arrives, we mark him as being in the building. Just going to move this over a little bit more. That's Bob arriving in the building. And we can then create exactly the same thing for saying Bob left. It matches the same ID, but this time it comes from an NFC code reader that's installed on the inside of the building. And we can connect that to the reset. And that switch then shows us if Bob is in the building or not. Bob at work. And rather than putting that to controls, we can give this a different category. We could say, let's put that into the info category. And let's put that into whole house or whole building. If we want to do the same for Jane, what we can do, we can essentially copy this lot. But this time we want this to be Jane. So we say this has to be her user ID. And let's just rename this as well. Jane left, and then Jane arrived, changing it to her user ID. And this would be called Jane at work. And we can connect the text output to the same places. So NFC reader on the outside gets connected to Jane arriving, and hence turning this on. NFC reader on the inside gets connected to Jane leaving the building, and hence turning this off. And to prevent anyone from playing with these blocks, and checking themselves in and out when they're not there, we're going to protect these blocks using the user interface password. There we go. Let's save that in the mini server and see what that looks like. I'm going to first of all show you this in live view, and then I'm going to switch back to the user interface and show you what it looks like in the app. So here we go. We can see at the moment that both Jane and Bob aren't in the office. Let me zoom out, see if I can get this nicely on the screen. Zoom out one more time. There we go. So here we go. We can see that both Bob and Jane are at the moment not at work. If I now take Bob's key fob, I'm saying Bob is arriving. So he used the reader on the outside. Touch that to it. We can see that the door, of course, is unlocked, but we can also see that Bob's labeled, so if he's in the building, has now gone to on. Jane's, on the other end, has stayed on off. If I take Jane's key fob, I do the same thing. Jane arrives. Here we can see Jane has arrived. And if Jane now pops out to maybe go to the post office, then we can see Jane's gone out. And we can do the same with Bob and say, Bob's gone out again. If we have a look at that in the user interface, then we can see under info, we can see whether Bob's at work or Jane's at work. At the moment, neither is. And then again, as they're coming in, we can see Bob's actually there. Oh, sorry, that was Jane logging out. And here we have Jane coming in to work. Then we can have Bob leaving and Jane leaving. So as long as people are using their key fobs, we can now tell who is actually in the building. The next requirement was to make sure that in case of a fire alarm, these statuses actually get frozen. So that if then someone is leaving them, let's say Bob is in the building, let's assume the fire alarm now goes off, but Bob leaves through the front door. And just out of habit, he actually touches his key fob to the reader. This would at the moment change his state. That's what we want to prevent. So we want to prevent the state changing. We don't want to prevent the door from unlocking. In the case of a fire alarm, it's probably automatically unlocked anyhow. But we want to stop the state from changing. And the way we can do that is by using the disable input on the switch block. Disable input is an input that you find on most function blocks. And what it does, it disables any of the inputs to the block itself. So it would ignore any of the signals arriving. And so what we need is we would have our fire alarm somewhere. Now, I'm not going to create a fire alarm block. We've got, of course, a function block for fire alarm. As you can see here, fire and water alarm. I'm not going to use that for ease of simulating this. I'm going to assume that I've got a fire alarm somewhere here on another page. But instead of actually using a fire alarm block, I'm just going to use one of my inputs on my demo case to pretend that this is a fire alarm. This could also be an input from actually a different fire alarm panel, like a commercial fire alarm panel or something. And I am going to put that straight to the disable input on Bob and straight to the disable input on Jane's block there. So this means that when the key fobs are used, the door release will still work, but the actual status of these blocks in case of a fire alarm will no longer change. We can have a look at that quickly if we save again in the mini server. I'm going to switch back again to the user interface. There we go. Bob is arriving at work. So is Jane. Let's have Jane arriving at work. And let's assume that now the fire alarm is going off, which was my input 1 on my demo case. I'm just going to turn that on. If I show you this in live view, you'll be able to see that my input here has been turned on, and hence we have got here the disable input on. And if you watch closely, I am now going to use Bob's tag, and I'm leaving the building. And you can see that the reset actually came on, but that the output hasn't changed. That's because the disable thing. I'm going to do that again. You can see reset is being triggered, but the output doesn't change. That input is being ignored due to the disable input currently being on. So in the user interface, what's happening is that we've frozen the state of these blocks, and hence we can now use that as a fire register. Of course, such a register could also, as Hugh was showing on Friday, be written out directly to a CSV file. So if you're interested in that, then please, again, refer back to the webinar that we did on virtual outputs, so that you could actually create yourself a CSV file or something that could then be printed out that isn't just on the user interface. Now that covers the basic solution that we talked about, or that was asked for in today's config challenge. And then the little additional extra bit was to try and create a work time monitoring system that would monitor the hours that someone is actually at work. So let's keep that over here. And what we'll do is we'll build up our work time monitoring system over here. Now we have got already very handily a signal here that tells us when someone is actually in the office. So all we need to do is really count the number of minutes or hours that someone is now in the building. And the easiest way of doing that is to simply count the number of minutes that someone is there. So a block that we can use for that is the counter. And the counter block simply counts every time it receives a pulse on TR. So if we want to count minutes, then we have to create a pulse every minute that either Bob or Jane here are at work. Now, if you're working out how many minutes are in a normal work week, then you'd have to take 40 hours times that by 60. That is 2,400. So the maximum or the limit that you need to set here has to be increased so that you can actually count that file on this counter. Since I like people working more than 8 hours a day as an employer, I'm going to set that number to 4,000. That's definitely enough. I could also work out what 24 hours is, 7 days a week, and set it to the maximum of that, so 24/7 workforce. But let's be a bit humane. Let's say 4,000 minutes here. That's the maximum number we want to count to. We then need to somehow not just connect this, because that will just go on once when Bob arrives at work, but we need to create pulses once per minute. And of course, one block we can use for that is the pulse generator. But there are other ways of doing this as well. The pulse generator is a block that Hugh has used in several other examples. So I'm not going to use that block today. I could, of course, here set myself up the durations. But something that is often overlooked in Logs on Config is this section here called times. Times gives us all sorts of time-based variables, such as sunset, sunrise, which is where you might know this from. But there's also various pulses that are being created. So pulse for each hour, a pulse for each day. And there's also a pulse per minute. So once a minute, this actually pulses, goes on. Now, if I connected that there, it would simply count 24/7, would increase the counter. So I need to somehow combine my signal from over here to say, if Bob is at work and a minute passes, then count up. So as I've just said there, the block that we are going to use instead here is the AND block. And we're going to say, if Bob is at work, and a minute passes, so the pulse of a minute, then we want to increase our counter value. So this would now count up for every minute that Bob is at work. So the output would give us a number of minutes that Bob's at work. Now, I could do the mental maths and try and work out, well, how many hours does that equate to? Or I can, of course, again, get the mini server to do that for me. And to get from minutes back to hours, we need to divide by 60. So I am going to do that with a formula block. Formula block, just if you haven't used it, allows you to have 4 different inputs, 4 different analog values that you can use to then create any type of mathematical formula to give you an output. Now, the formula gets simply typed in here, and I can say I1 because I'm using AI1 there, so input 1, and I want to divide that input by 60. So that would get me from minutes to hours. So once I now have my hours, I then just need a way to display that on the user interface. And a way I could display this, oh, apologies about that. F5, a way to display this on the user interface could be the virtual state. Virtual state is intended for exactly something like this, just to show status on the user interface. And I could say that this virtual state block is called Bob's working hours. Connect that up. See if I've still got enough space here to put it next to it. Yep, there we go. Let's pop that there. I'm just going to move this over slightly. So that's Bob's working hours. And on that virtual state block, the other thing we might want to define is how that's displayed on the user interface. So we can say here how it's displayed as a value with 1 decimal point. So it would say 1.5 hours, 1.2 hours, whatever. And to actually explain what it is, I can type hours after that, or abbreviate this to hours like that. And I can now say, where do I want this to be displayed? I could say I can display that in the same place as I have got the other things. So in info, under whole house, and that would be Bob's working hours. Save that in the mini server, and we'll be able to see that working. I'll swap here to my user interface. We can create the same thing, of course, for Jane as well. Categories, info, so at the moment, no one's there. Bob's working hours. Bob has worked 0 hours so far this week. I'm just going to use Bob's tag here, check him in. Now, of course, we'd have to wait quite a while to see these values starting. Oh, sorry, who's this? Let's make sure we get, I've still got my fire alarm on. That's why the state isn't changing. Let's change that. Here we go. Bob at work. So now we'd have to wait quite a while for this counter to start going up and to give us any reasonable values there. Because of course, only once a minute does it actually count up, and then it divides the number of minutes by 60 and shows that there. So we'd have to wait 6 minutes to actually get to 0.1. So I'm just going to show you this in live view so that you can see something is actually happening there. So we can see at the moment it's gone to 1 minute already, our counter. The formula block is then dividing that, which is 0.017 hours that he's currently worked. Hence, being rounded to just 1 decimal point is still not showing us anything. But that's a configuration that you'd want, and we can copy this to create exactly the same for Jane. So we do copy, paste, pop this back down, have the same exact thing for Jane, and just call it Jane's working hours. And that's it. That could be our capturing for the time. The last bit that we need, if we want this to be incrementing over the week and then shows at the end of the week what the value is, we then would want it to reset. Let's assume we're working a Monday to Sunday week. So every Sunday we would want to reset these counters. That means we need something to trigger the reset input on these. So I'm just opening up here, showing the 2 reset inputs. And rather than that being a manual thing, let's make sure that that happens automatically. And we can again use something from the time section here. In the time section, we have got the weekday, and we can see the current day of the week is given as a value from 0 to 6, where 0 is Monday. So if I grab myself this day of the week, so Sunday is 6, and on Sunday I wanted to reset, I can now simply create myself a constant. I'm going to call that constant Sunday. And I'm going to give that a value of 6. So this is how you can create yourself different values that you maybe want to compare something against, or that you want to use for other things in your configuration. Create yourself a constant, give it a value there called Sunday. We could say if the weekday is equal to Sunday, i.e. 6, then we want to reset our counters. Now, specifically haven't connected my constant down here because it's going to throw up an error message. I want to read that one out to you. So when I connect this up, it actually tells me you're trying to add a constant to the function block. This constant can also be set directly at the block input. Do you want to set the input value and disconnect the constant? So it's basically telling me here, look, you're putting a constant and it's never going to change. You can also set this directly in the function block. I'm going to say no, because then I have it very explicitly here of what the configuration file is doing. So anyone that looks at this config file can straight away see what am I doing. For yourself, once you're getting comfortable with this principle of using these different blocks, you can save yourself some time and actually not connect that. And instead on the function block, set the value directly in here. Just put a 6 in there. So we can see that input 1 is set by logic, by what is connected here. And input value 2, we can just set as a fixed value to 6. That's something you can do there. But it looks almost like something has been forgotten there, or that it's incomplete. Hence, to make it explicit, you might want to use a constant and actually connect the constant up to it. Say, yes, I acknowledge that error message. And then it says you that both values here are now being set by the logic that you've got connected to that block. And that is it. This gives us the presence monitoring for every employee in the building. Makes sure that the presence doesn't change whenever the fire alarm goes off. And over here, we've got the monitoring of their working hours throughout the week, which goes up as the week goes on, and then every Sunday gets reset. Thank you very much.